Okay, good day, everyone. On today's session, we'll be focusing on the application of differentiation. So for the past 3 weeks, what we've been doing is we studied differentiation and their rules, the rules of differentiation. So on today's section, we'll be applying that differentiation to our equation. Like we'll be using the differentiation to find marginal revenue and cost function from the total revenue and the cost function. Okay, starting from the marginal revenue function. Okay, starting from the marginal and revenue and average. Functions. Okay. What we know about the differentiation is that the derivative of any function is the rate of change of that function. For example, the rate at which the total revenue changes is called the marginal revenue. Okay, that simply means to find the marginal revenue, we have to differentiate the total revenue. Okay, this means the rate of change of the total revenue is called the marginal revenue. Okay, so find the marginal revenue, you have to differentiate the total revenue. And another thing, the rate of change of the total cost is called the marginal cost. This means to find the marginal cost, you need to differentiate the total cost. So this means the marginal revenue is the derivative of the total revenue, and the marginal cost is the derivative of the total cost. Like, to get the marginal revenue, we differentiate the total revenue, and to find the marginal cost, we differentiate the total cost. Okay, now suppose we are given our demand function as in P equals A minus BQ, where Q represent the quantity and P represent the price, and A and B, those are constant. Okay, if we were given a demand function like this, we need to apply our differentiation derivative, application of the derivative, then we need to find the total revenue. Remember, we said the derivative of the total revenue is the marginal revenue. So to get the marginal revenue, you need to first find the function for that represent the total revenue, and then from there we can differentiate that function to find the marginal revenue. Okay, if you are given a demand function, remember that the total revenue, we find the total revenue by multiplying the demand function with the number of units demanded. Okay, so this means our total revenue would be P times Q, right? And we know that P is equal to A minus BQ. So if we substitute this back here, we'll have A minus BQ times Q, right? And then we can simplify these brackets by multiplying everything inside the brackets with Q. So we'll have A times Q, and we'll have Q times minus AB. So we have A times Q, that give us AQ, right? And then we have minus BQ times Q, that give us minus BQ squared. So this is our total revenue, right? And then we said to get the marginal revenue, we need to differentiate the total revenue with respect to Q. Okay, and now that's the total, our total revenue is AQ minus BQ squared over DQ, right? Okay, remember that A and B, those are constant, right? Okay. To find the derivative of this, it's easy because we can use the power rule. Remember the first rule we did under differentiation, which is the power rule. That's what we'll apply here to find the marginal revenue. Okay, let's if we differentiate AQ, we'll find A. And if we differentiate minus B, Q squared, we should get minus 2BQ. Okay, then this is our marginal revenue if you are given a demand function as in this function. Okay, this is what you should obtain as your marginal revenue. A minus 2BQ. Okay, let's do an example. Suppose you are given your demand function as in P equals 36 minus 1 over 2Q. And you are asked to determine the marginal revenue. Okay, we said the marginal revenue, we can find the marginal revenue by differentiating the total revenue. So we have marginal revenue equals the derivative of the total revenue with respect to Q, right? But we don't know what the total revenue is. We don't know what the total revenue is, but we can find the total revenue because if you are given the demand function to find the total revenue will be obtained by multiplying the demand function with the number of units demanded. So we have total revenue equals P times Q, and we know that P is equal to 36 minus half. So we have 36 minus 1 over 2 Q times Q. Okay, if you simplify these brackets out, you should get 36Q minus 1 over 2Q squared, right? This is what you'll obtain as your total revenue. So we can now substitute our total revenue here and then differentiate it, find the derivative of it, and that will equal to, that would be our marginal revenue. So this means we have E 36Q minus 1 over 2Q squared respect to Q. We're differentiating with respect to Q. Okay, again, even here, we still use a power rule. You see, we have a polynomial, so we can use the power rule to differentiate this. Okay, if we differentiate 36Q with respect to Q, we'll get 36, right? And we have minus 1 over 2. If we differentiate this, we should get 2Q, right? And you can simplify this further. And if you do this, you should get 36. So we have minus half times 2. That gives us 1. So that means we have 36Q. This is your marginal revenue. Okay. Suppose we are asked to find the revenue after the 16 units have been sold. Okay, if you are asked to find the marginal revenue after the 16th units have been sold, you have the marginal revenue equation. You just have to substitute your 16 here on the marginal revenue where there is Q, there is quantity. So this means we'll have 36 minus 16. If you punch this in your calculator, you should get 20, meaning we have 20 Rand as our marginal revenue after the 16th units have been sold. Okay, this simply means the 17 units to be sold will generate an income of 20 Rand. Meaning after you have sold the 16 units, if you add one more unit, if you sell one more unit, that's one more unit will give you an income of 20 Rand. I hope that's clear. Okay, let's move on. Okay, our next topic is the marginal cost. Okay, we need to find the marginal cost. The marginal cost. All right, remember at the beginning of this session, I said you will find the marginal cost by differentiating the total cost function. Right. Now, suppose we are given a total cost function as in total cost equals fixed cost plus variable cost. Right. Remember, okay, we said to find the marginal cost is the derivative of the total cost. So this means marginal cost is equal to DC with respect to Q. Right. But we know that our total cost is equal to fixed cost plus a variable cost. So this means we have the fixed cost plus variable cost with respect to Q, right? Okay, but we know that fixed cost is a constant. It's just a fixed amount. It's a fixed variable. It doesn't vary. So it's meaning it's fixed, meaning it's a constant. It doesn't have Q in it. Since it doesn't have Q, we know that the derivative of the constant, is 0, right? So this means we have the derivative of fixed cost with respect to Q plus the derivative of variable cost with respect to Q. We said fixed cost is a constant, right? And we know that the derivative of a constant is 0. So this means the marginal cost is equal to, okay, this gives us 0. If this gives us 0, this means the marginal cost is the derivative of the variable cost. All right. So we said the marginal cost is the derivative of the variable cost. Okay. So since the marginal cost is the derivative of the variable cost, this means since, okay, one thing you should know is that the derivative of the variable cost is the marginal variable cost. So the derivative of the variable cost is equal to the marginal variable cost. So this means marginal cost is the same, it equals to marginal variable cost. So this is, you can even just go straight to here. If maybe you are given a marginal variable cost and they ask you to find the marginal cost. You can just take that marginal variable cost and say that is your marginal cost, and you can prove it like this. Okay. Let's do an example here. Okay. Suppose we are given a total cost as in 300 plus 50Q, and we are asked to find the marginal cost, right? We said the marginal cost is the derivative of the total cost, right? So this means if you substitute the total cost here, we'll have D of 300 plus 50Q with respect to D. This is just a constant. And if you look at this equation, you have the fixed cost, you have the variable cost, right? We said the derivative of a constant is 0. So this means we have D 300 with respect to Q plus D 50Q with respect to Q. We said the derivative of the constant is 0. So that means we have D 50Q, which is with respect to Q. And this is the variable cost, right? And the derivative of 50Q is 50. Is 50. So this means the marginal cost is 50. Okay, and this means each additional unit will cost 50 rand. Will cost 50 rand. Okay, here the marginal cost doesn't vary because it's a constant. It doesn't vary with anything. Each additional unit will always cost you 50 rand, because in this case it doesn't vary. It doesn't have Q's. It's not a function, it's just a constant. So it will always cost you this amount. Okay, let's do another example which won't give us the marginal cost as in the constant. Okay, suppose we are given a total cost, as in total cost equals Q cubed minus 1 over 2 Q squared plus 100, right? Okay. If you were to find the marginal cost, we said the marginal cost is the derivative of the total cost, right? And the total cost is given as Q cubed minus 1 over 2 Q squared plus 100 with respect to Q, right? If you differentiate Q cubed, you should get 3 Q squared, and you differentiate minus half Q squared, you should get minus Q. You differentiate 100, you will get 0. So this means our marginal cost is equal to 3Q squared minus Q. Okay, suppose we are given a quantity as 10, and we are asked to find, like, after producing or selling 10 units, what would be the cost of one more unit, like the 11th unit? Okay, let's say we are given a quantity as 10, meaning Q is equal to 10. Okay, if you were asked to find the cost of producing one more unit after producing 10 10 units, right? This is what you'll do. You have the marginal cost, you just substitute this 10. So this means we have marginal cost of 10 equal to 3 10 squared minus 10, right? And if you punch this in your calculator, you should get, let me see, this will give us 300 minus 10, or you should get 290. So this means the cost to produce the 11th unit is 290 rand. Okay. Cost to produce the 11 units is 290 rands. It simply means this. Okay, let's, sorry about that. Okay, let's move on to the average revenue and the average cost. Okay, we have the average revenue and average cost. Please don't confuse them, the marginal revenue and the average revenue, and the marginal cost with the average cost. These are total different. You calculate them different. Sometimes you do the calculations and find that they are the same, but sometimes they are not the same. Sometimes they are not just a constant, they vary. They depend on Q, on the value of Q. So just make sure you don't confuse these two. Okay. The average revenue, this is the average revenue per unit sold, meaning you will find the average revenue by dividing the total revenue with the unit sold, right? Let's say you find the total revenue of selling 5 units to be 150, right? And then this means the average revenue, you'll find the average revenue by saying 50 divided by 5, because we said if the total revenue of selling 5 units is 150, then to find the average revenue, you'll say 150, which is the total revenue, divided by the number of the units you sold. Okay. If the average revenue is equal to total revenue, if the average revenue is equal to total revenue divided by Q, this simply means the total revenue is the average revenue times the units the quantity demanded, or just the units sold or produced and sold. Okay, so this means the total revenue is equal to the average revenue times Q. But we know that the total revenue is equal to the quantity demanded times the demand function, right? So if the total revenue is equal to average revenue times the quantity demanded, and we know that again the average revenue is equal to P times Q, we can just substitute where there is the total revenue here, we substitute with this. If we do that, so this means we'll have P times Q equals A, 8R, which is average revenue, times Q, right? So you see from this, since Q is common on both sides, we can divide by Q on both sides. You see, Q and Q will cancel out, and we'll have P equals average revenue. And P is given by the demand function, right? So this simply means the average revenue is the same as the demand function. Okay, let's do an example. Okay, not an example for now. But for now, you should keep that in mind, that this is what we'll obtain, right? Okay, another thing, let's move on to the average cost. Now, remember I said we were focusing on the average revenue and the average cost. Okay, the average cost is the total cost divided by the number of units produced. This means the average cost is equal to total cost divided by the number of units produced. Okay, if this is the case, this means the total cost is the same thing as the average cost times the number of units produced. Okay, now let's do an example here, so that I make sure you don't confuse all of them. Don't confuse the marginal revenue, the average revenue, the marginal cost, and the average cost. Okay, suppose this. Okay, this is example 4. Suppose we are given the fixed cost. The fixed cost is 60, and we are given the variable cost is 1/3 Q cubed plus 2Q squared plus 5Q. And we are given the demand function as in P equals 100 Q minus 3Q squared. And okay, we are given this information, and we are asked to find the marginal cost, the marginal revenue, the average revenue, the average cost, and the marginal cost. Suppose we are given this information, and we are asked to find these for marginal revenue, average revenue, average cost, and the marginal cost. Okay, remember I said don't confuse all these. We said the marginal revenue is obtained by differentiating the total revenue with respect to Q, right? But the marginal cost, is fine. Oh, and the marginal cost is found by differentiating the total cost with respect to Q. And then the average revenue is found by dividing the total revenue with the number of units produced or sold, and then sold. And then the average cost is found by dividing the total cost with the number of units produced. So we have TC over Q. Okay, this is what we will use. We'll use this to find the marginal cost, this to find the marginal cost. Okay, the marginal cost, and then sorry, I need to put in my charger. Okay, I'm sorry about that. I had to put in this. Okay. You see, in all these, so we need the total revenue and the total cost. Because to find the marginal cost, we need to differentiate the total revenue. To find the marginal revenue, we need to differentiate the total revenue. To find the average revenue, we need to divide the total revenue with the number of units produced, sold. And then to find the marginal cost, we need to differentiate the total cost. And to find the average cost, we need to differentiate, to divide the total cost with the number of units produced. Okay, this simply means to find these four, we need to find the total revenue, and we need to find the total cost, right? What are let's check what are we given in order. It's just to check if it will help us find these two. Okay, we have the fixed cost, we have we have variable cost, we have the demand function. Okay, we know that the total revenue is the demand function times the quantity to be sold, right? The number of quantity. And then we know that the total cost is the same thing as fixed cost plus the variable cost. We have these two, we have this. We know that the demand function is 100Q minus 3Q squared, and we multiply this by Q. Okay, and if we multiply this by Q, you will get 100Q minus 3Q cubed. So we have the total revenue, right? We said to find the marginal revenue, we need to differentiate the total revenue. Okay, so this means we need to find the derivative of 100Q minus 3 cubed with respect to Q, right? And if we differentiate this, you should get 100 minus, so we have 3 times 3, that's 9Q squared. This is our marginal revenue. Okay, and we said the average revenue is found by dividing the total revenue with the number of units sold. So we have that, we know that the total revenue is equal to 100Q minus 3Q cubed over Q. We are dividing this with Q, right? And if we divide this with Q, we have 100Q divided by Q. That will give you 100. And we have minus 3Q cubed divided by Q. That will give us minus 3Q squared. This is the average cost. You see, it's not the same. It's not always the same. We have marginal revenue equals 100 minus 9Q squared, and we have the average revenue equals 100 minus 3Q squared. Okay. Remember, we asked to find the average revenue, or the average cost and the marginal cost. We said we have the fixed cost as in 60, and we have the variable cost as in 1/3 cubed plus 2Q squared plus a 5Q. And we know that the total cost is equal to fixed cost plus a variable cost. And fixed cost is 60 plus the variable cost is 1/3 cubed plus 2q squared plus 5q, right? Okay. We have the total cost. You can use the total cost to find the marginal cost. We know that the marginal cost is equal to the derivative of the total cost. Right, so this means the marginal cost would be d/dq of 60 plus 1/3 cubed plus 2q squared plus 5q. If you differentiate this, the derivative of 60 is a constant. The derivative of constant is 0. Okay, let's move on to another. The derivative of 1/3 cubed, that will give you q squared. The derivative of this will give you plus 4q. The derivative of this will give you plus 5. This is the marginal cost, right? Okay, we said we need the average cost too. We know that the average cost is equal to the total cost divided by the number of units produced. So we have, this means we'll have 60 plus 1/3 cubed plus 2q squared plus 5q over q. If we divide this, we have 60 over q. That will give you 60 over q. We have 1/3 q cubed divided by q. That will give us 1/3 q squared. And we have 2q squared divided by q. That will give you 2q. And we have 5q divided by q. That will give us 5. This is our average cost. You see, they are different. So please don't confuse the two. Okay, I hope we don't have questions, but you can email me after going through this video if you feel like you have questions. Okay, let's move on to the production function. Production functions. Okay. So here we'll look at the marginal production of labor and the average production of labor. Okay, we'll use MPL to denote the marginal production of labor, and we'll use APL to denote the average production of labor. Okay, now suppose we are given a labor function Q, which is a function of L, This means we have Q equals Q of L, since Q is a function of L, since Q depends on L, right? Okay. Again, I said, suppose you are given a labor function Q, which is of a function L, meaning Q is equal to QL. Okay, this means during the production process, we have an input L and Q as the output, right? That means that. Okay, now the marginal production of labor is given by differentiating the labor function, that is Q. Remember, the labor is given by Q. And now I'm saying the marginal production of labor, which means MPL. We'll find this the marginal production of labor by differentiating the labor function, meaning we'll have the Q dL with respect to L. We're differentiating the labor function, which is Q, with respect to L, right? And the average production of labor, which is APL. This is found by dividing the production function with the number of labor units, meaning the average production of labor is equal to Q over L. Remember, L represents the labor units and Q represent the production function. So to find the average production of labor, we divide Q by L. And to find the marginal production of labor, we differentiate our production function, which is Q, with respect to L. Okay, let's do an example here. Suppose we are given our production function as in Q equals 8L squared minus 1 over 3 L cubed. And we are asked to find the marginal production of labor and the average production of labor. Okay, going back to this equation, we said the marginal. The marginal production of labor is found by differentiating the production function with respect to labor. So this means we have dQ over L. And we know that our Q is 8L squared minus 1 over 3 L cubed. We are differentiating with respect to L. If we differentiate 8L squared with respect to L, we should get 16L. And if we differentiate 1 over 3 L cubed with respect to L, you should get minus L squared. So this is our marginal production of labor. Now, what would happen if five workers were employed? What would be your marginal production of labor? Suppose you are asked that question, right? If 5 workers were employed, what would be the marginal production of labor? Okay, you have the marginal production of labor function, which is 16L minus L squared. Now we are asked to find the marginal production of labor if 5 workers are employed, we hired. So this means we'll have MPL of 5. And this would give you 16 times 5 minus 5 squared. So we have 16 times 5, that's 80 minus 25, and this is 55. Okay, so this means when 5 workers are employed per day, employing an additional worker will increase daily production at the rate of 55. Yeah. Suppose you are asked to find the average production of labor too. Remember, we said the average production of labor is equal to the production of labor function divided by the number of workers, the labor. Okay, so we know that Q is equal to 8L squared minus 1 over 3 L cubed. Okay, we're dividing by L. If we divide by L, you should get 8L minus 1 over 3 L squared. Okay, this is your average production of labor. Okay, now suppose you are asked what would happen if 5 workers were employed per day? What is the average production of labor? Okay, you have the average production of labor function. Just take your 5 and substitute there. If you substitute 5 here, we'll have average production of labor of 5 units as 8 times 5 minus 1/3 times 5 squared. If you punch this in your calculator, we have 8 times 5, that is 40. You have 5 squared, 1/3 times 25. Okay, if you punch this in your calculator, you should find 95/3, and this is 31.66, which is equivalent to 32. All right, so this means the average production per worker is 32 units. Simply means the average production per worker is 32 units. Suppose you are asked to find the total daily inputs of our 5 workers. Okay, we know that the average production of labor, the average productivity per worker is 32, right? And then now we're asked to find the total daily output for 5 workers. So we have average production of labor as in Q over L. Now we are asked to find Q, right? Given L is 5 and APL is 32. So this means we have Q equals average production of labor times labor. And we know that average production of labor is 32, and we are told that the workers, we have 5 workers, so we have 32 times 5. That will give us 160. So this means the total daily output of 5 workers is 160 units. Okay,